Inshallah, this is the first part of system of circles. So let me revive few formulas which are useful in the problems. Okay. So I'm not going in detail. I'm just using the definitions and formulas which are necessary in the solving the problems. You see, a set of two or more circles is called system of circles. Whenever we consider two or more circles, we say that it is a system of circles. The locus of a power of point, we know what is power of point. S11 is called the power of point, which is equidistant from two circles, is called radical axis. It's called radical axis. Suppose the radical axis will be always perpendicular to the line of centers. We get a line if you subtract two circles. If you subtract two circles, you will get a line which is perpendicular to the line of centers. This is called radical axis. In short, we can write RA, radical axis. So remember this, whenever we subtract two circles, we'll get a line that is called the radical axis. A definition is given here. Now watch carefully, we'll get three types of radical axis. Suppose the circles are like this, so you generally get a radical axis in between them. Okay, but if the circles are touching externally at a point, then the radical axis will become the common tangent. If the circles are intersecting circles, then the radical axis is the common chord. So for these three, we'll have the same formula. Equation of radical axis is s minus s dash equals to 0. Equation of common chord is same, s minus s dash equals to 0. Equation of common tangent at the point of contact is also same, s minus s dash equals to 0. So whatever we say, radical axis, common tangent, common chord, we will use the same formula, s minus s dash equals to 0. Next topic, you see, if different pair of circles have the same radical axis, then such circles are called coaxial system of circles. If different pairs of circles have the same radical axis, then they are called the coaxial system of circles. Coaxial system of circles. Now, whenever we consider coaxial system of circles, any circle in the coaxial system of circle can be taken as like this. You see here, lambda 1 s1 plus lambda 2 s2 equals to 0. Any circle in the coaxial system we can take like lambda 1 s1 plus lambda 2 s2 equals to 0, or we can just take s1 plus lambda s2 equals to 0, where s1 and s2 are the two members of radical axis, are the two members of coaxial system, are the two members of coaxial system. Also we can take in one more way, s1 plus lambda l equals to 0, where L is the radical axis, or else we are having like this. You see, watch carefully. For all this we have the same method. Suppose there is a line passing through the circle and cutting the circle, then it circle passing through the point of intersection of the circle and the line L equals to 0, circle S equals to 0, then the line passing through this point of circle intersections can be taken as S plus lambda L equals to 0. So whenever either in coaxial system or having the radical axis L, we can take S plus lambda L equals to 0. Any circle passing through the point of intersection can be taken as S plus lambda L equals to 0. Circle and line. Okay. So any circle passing through the coaxial system of circles which S1 equals to S equals to 0, S dash equals to 0 are two members can be taken as S1 plus lambda L equals to 0 or S plus lambda L equals to 0, where L is the radical axis. Length of the common chord, we are having the formula 2 into under root of r square minus d square. D is the distance of the line from the center of the circle. Now what is radical axis is always perpendicular to the line of centers. Just now we have seen radical axis is always perpendicular to the line of centers. See here, suppose we are having three circles. Okay, suppose if we take the radical axis of these two circles, suppose this is the radical axis of these two circles and radical axis of these two circles, then watch carefully, taking pairwise the radical axes of three circles, they intersect at a point, that is they are concurrent, passing through the same point, three radical axes of three circles taken pairwise are concurrent, and this is called, this center is called, this point is called radical center. This point is called radical center. Now angle between the two circles, when we say angle between the two circles, it means the angle between the tangents of two circles at the point of contact. That is given by cos theta equals to d square minus r1 square minus r2 square by 2 r1 r2, or we can use this formula also. Cos theta equals to c plus c dash minus 2 g g dash minus 2 ff dash by under root of, that is r1 r2, sorry 2 here, 2 r1 r2. So 2 into r1 r2. See, if the angle between the two circles is 90 degrees, then this cos theta will become 0. So if you bring this here, it will become 0. So the condition will be 2g g dash plus 2 ff dash, to take minus common, or bring this here equals to c plus c dash. So condition for orthogonal circles is 2g g dash plus 2ff dash equals to c plus c dash. Or we can write like this also, d square equals to r1 square plus r2 square. Now radius of a circle which is orthogonal to three circles is given by, suppose this is the circle orthogonal, okay. Now the from center, this three distance will be equal, okay. This three distance, that will become the radical axis of the circle which is orthogonal to the three circles. Radius of the circle which is orthogonal to the three circles. Therefore we can use the, for radius of the circle, we can use the formula r equals to under root of s11. So these are the few concepts, few formulas we have seen. I request you all to first go through these formulas, revise this all, okay, then only you go into the problems, okay. We will do few questions based on these formulas, and if something new concept comes there, inshallah we will discuss there itself, okay. So let me start the question. Now see here, this is very favorite question of them, Eamcet question. The equation of circle whose diameter is the common chord of the circles. Common chord of the circle. Suppose you see here, s equals to 0 is one circle, s dash equals to 1 0 1 0. We know if we subtract this 2, we'll get radical axis, that is the common chord here. So this common chord, the question is given that we have to find a circle whose diameter is the common chord of these two circles. So we have to draw it. We have to find a circle. Suppose we are finding this circle whose diameter is the common chord of these two circles. So first let me find the common chord, that is radical axis. If you subtract these two circles, you'll get the common chord, either radical axis or common chord or common tangent at the point of contact. We are having same method. So if you subtract this you see, you change the sign, this will get cancelled, plus 2x minus 2x also get cancelled, 3 plus 3 6y plus 6 equals to 0. Take 6 common, so this is the radical axis or common chord. So just now we have seen, now we can take any circle in the quadratic system like this, s plus lambda l equals to 0. Now to how to find any circle in this radical quadratic system, we can take s plus lambda equals to 0. We can take one of this as s, either you take this or this as s. So I am taking this as s, x square plus y square plus 2x plus 3y plus 2 equal, sorry, plus lambda into l. L is y plus 1 equals to 0. So if you multiply and take the coefficients common of x and y, you'll get it. Just wait. Now see here, we just you write first x square as it is, then y square as it is. Now x term we are having only 1 2x. See here we are having two terms of y. If you take y common, you left 3 here. If you take common y, you left with lambda here. The constants are 2 plus lambda into 1 lambda. 2 plus lambda equals to 0. Suppose this is the equation we required, but we have to find the value of lambda. How can we find the value of lambda? This common chord is the diameter, so we can substitute the center of this line on the common chord. What the common chord we are having, y plus 1 equals to 0. So if you substitute, because this common chord is the diameter, so center of this circle must lie on the common chord, that is diameter. So what will be the center here? Center will be minus g. The value of g is here half this one 1. G is 1 here. F is 3 plus lambda by 2. So center will be minus g comma minus f minus lambda by 2. Now if you substitute this in the coordinate common chord, this is the diameter of the circle, you get the lambda. Now substitute here, this is x, this is y. So if you substitute y here, minus 3 minus lambda by 2 plus 1 equals to 0. If you take LCM, 2 ones are 2, 2 ones are 2, minus 3 plus 2 minus 1 minus lambda equals to 0, or lambda equals to get minus 1. Now if you substitute the lambda value minus 1, here we are having, sorry, y. If you substitute the value of lambda minus 1, you get the answer. So x square plus y square plus 2x. Now if you keep lambda here minus 1, 3 minus 1 will be 2, 2y. If you keep here minus 1, 2 minus 1 will be plus 1 equals to 0. So this is the equation of the required equation. X square plus y square plus 2x plus 2y plus 1 equals to 0. Now you see the next question. If x minus y plus 1 equals to 0 meets the circle at A and B. Same method, suppose this is the circle. Suppose this is the line x minus y plus 1 equals to 0. Meet the circle at A and B. Then the equation of the circle with AB as diameters. So we have to find a circle whose diameter is AB. We have having the same concept. Suppose this line is L equals to 0, this circle is x equals to 0. Then the equation of any circle passing through their point of intersection is taken as S plus lambda L equals to 0. So S is the circle, x square plus y square plus y minus 1 plus lambda into line is x minus y plus 1 equals to 0. Now how to find, this is the diameter line, this line is the diameter, so we have to substitute the center on this line. The question is that this line is the diameter, so we have to find the center and substitute here, we will get the value of lambda. Again substitute here lambda, we will get the value of equation of the circle. X square plus y square, you are having lambda x plus lambda x. If you take y common, here you left with 1. If you take y common, you left with plus into minus lambda into y. Now lambda into 1, lambda minus 1 equals to 0. So we got the general form. Now what is the center here? Minus g. G is here lambda by 2. Minus g means minus lambda by 2. Minus f, you multiply minus, this will become plus, this will become minus. Lambda minus 1 by 2. Now this is the center. The question given that this is the diameter, so this center should lie on this. So in place of x, you substitute minus lambda by 2. In place of y, you substitute lambda minus 1 by 2 plus 1 equals to 0. Now solving this, we'll get lambda. You take LCM, 2 ones are 2. Minus lambda, minus into plus, minus lambda, minus of minus, plus 1, plus 2 ones are 2 equals to 0. Minus 2 lambda, if you bring this here, it will be 2 lambda equals to 3. 2 lambda equals to 3. So the value of lambda will be 3 by 2. The value of lambda will be lambda equals to 3 by 2. Now let me substitute here or here, no problem, I am substituting here. So let me substitute this x square plus y square plus y minus 1 plus 3 by 2 into x minus y plus 1 equals to 0. Now we take the LCM, 2 into x square is 2x square plus 2y square plus 2 ones are 2 y minus 2 ones are 2 plus 3 into x 3x minus 3y plus 3 equals to 0. 2 into x square, 2x square, 2 into y square, 2y square, 2 into y, 2y minus 2 plus 3 into x 3x plus into minus 3y plus 3. Now the last step, how can we change 2x square plus 2y square? We are having x here plus 3x. Now 2y minus 3y will be minus y. 3 minus 2 plus 1 equals to 0. So this is the required equation. You take common 2, x square plus y square. X square plus y square plus 3x minus y plus 1 equals to 0. So the first bit is the answer. Now see the next question. If the circle bisects the circumference of the circle, what does it mean? The bisect? Bisect means dividing into two equal parts. Suppose this is the circle, bisects the circumference of this circle, means bisect means dividing this into two equal parts. This is half circle, this is half circle. That means it is passing through the diameter. It is passing through the diameter. Okay, so sorry, the common chord will be the diameter. This is the common chord. So this, the common chord will the diameter of the second circle. This bisects the second circle. No, that means the center of the second circle, the center of the second circle lies on the common chord, lies on the common chord. So how can we find common chord? If you minus these two circles, you will get the common chord. That common chord will be the diameter of the second circle, diameter of the second circle. So if you substitute here, If you substitute the center, you will get the value of k. Okay, so first let me find the common chord. We have to subtract these two circles. One circle is x square plus y square plus 6x minus 2y plus k equals to 0. Another circle is x square plus y square plus 2x minus 6y minus 15 equals to 0. So this you minus this one, you will get this cancel. This is common chord 4x minus 2 plus 6 is plus 4y. 4x plus 4y plus k plus 15 equals to 0. This is the common chord. Now we got this one. No, but this is the diameter of the second circle because this is bisecting. No, this is midpoint, so diameter will pass through here. So we have to substitute the center of this. What is the center of this? Minus g. G is 1. Minus g means minus 1. Minus f. Minus 1 is plus 3. So substitute this. 4 into minus 1 plus 4 into 3 plus k plus 15 equals to 0. Now 4 3s are 12. 12 minus 4 is 8. 8 plus 15 is 23. Bring that 23 on the other side, it will be minus 23. So this is the answer. नेक्स्ट क्वेश्चन देखिए, आसान क्वेश्चन है 2001 में पूछा. सो द रेडिकल एक्सिस ऑफ द सर्कल्स. क्या करना, दो सर्कल्स को माइनस करना तो रेडिकल एक्सिस आते. साइन चेंज कर लो, माइनस 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 जाके प्लस, प्लस जाके माइनस, माइनस जाके प्लस. ये तो कैंसिल हो जाते. 8x माइनस वाई प्लस 1 इक्वल्स टू 0. सॉरी ये ना होता ना, 8x minus y plus 1 equals to 0. If the circles of same radius A and centers cut orthogonally, then A equals to. For orthogonal, we can use this condition: d square equals to r1 square plus r2 square. D is the distance between the centers. So distance formula is under. No need to write root now, we are having square. So x2 minus x1 whole square, 5 minus 2 whole square, y2 minus y1 whole square, 6 minus 3 whole square. What is given? Same radius of both the circles A, that is a square plus a square. So a square plus a square is 2a square equals to 3 square 9, 3 square 9, 9 plus 9, 18, 2 ones are 2 nines. So if we take our square from here, it will be root 9, take only positive value for radius. So a equals to 3. Now next question, find the radical center. Radical center of the three circles. What we have to find? We have to find two radical axes, either of 1 and 2 1 or 2 and 3 or 1 and 3. Let me find two radical axes. The point of intersection of radical axes will be radical center. Now I am doing one thing, first minus second. If you subtract this, you will get one radical axis. Change the sign, minus minus plus minus minus. 2x minus x will be x. 3y minus 2y will be y. 3y minus 2y will be y. Minus 3 minus 2 minus 5 equals to 0. In the same way, let me solve this one. Minus minus minus, you get cancelled. Minus 4x minus y plus 7. Minus 4x minus y plus 7 equals minus 4x. 2 minus 3 is minus y plus, sorry, plus 9. No, plus 9 plus 2 plus 11. No? Plus 9 plus 2 plus 11. I'm writing here minus 4x minus y plus 11 equals to 0. You add this one, solving this one, plus y minus y cancel. X minus 4x is minus 3x plus 11 minus 5, 6. Bring that on the other side, minus 6. Minus minus cancel, 1s are 2s. X equals to 2. X equals to 2. Now substitute here x2. 2 minus 5 minus 3. Bring that minus 3 on the other side, plus 3, y equals to 3. So the radical center is 2 comma 3. So this is the point 2 comma 3. Now see the next question. A circle passes through origin, has center on its line. If it curves the circle orthogonally, then its equation. Suppose you consider the general equation. Let the equation of circle be x square plus y square plus 2gx plus 2fy plus c equals to 0. Whenever a circle or a line passes through origin, it doesn't have the constant. The c will become 0. Okay, c will become 0 when it passes through origin. So take out this c here from here. Since it passes through origin, we can take this, because if you substitute origin 0 comma 0, you'll get c equals to 0. Next thing, center lies on the line. So if you substitute here, what is center? Minus g comma minus f. If you substitute in this line, you will have like this, minus f. Y is minus f equals to minus g, minus minus cancel. That is f equals to g. So in place of f you can write g, so this will become x square plus y square plus 2gx plus 2. In place of f you can write g, y equals to 0. The one parameter g is remaining. Okay, already we got c equals to 0, g equals to f. Next thing is it is orthogonal to this circle, so we can use the condition. Suppose what is here, x square plus y square minus 4x minus 6y plus 10 equals to 0. What is g here? Minus 2, f minus 3, and c 10. That we denote this by g dash f dash c dash. And what is here? We are having g. Okay, now what is the condition? These two circles are orthogonal, so we have to use the condition of orthogonal. The condition of orthogonal is 2g dash plus 2g dash plus 2f dash equals to c plus c dash. Now see, this is 2g into g dash is minus 2 plus 2f, this is 2f, f dash is minus 3, 2f f dash, 2f is also g, no sorry, equals to c. C is 0 plus c dash is 10. So this is minus 4g minus 6g is minus 10g. So minus 10g equals to 10. Therefore g equals to minus 1. Now left you substitute here g equals to minus 1. So you'll get x square plus y square. G is minus 1 plus into minus, minus 2 ones are 2x minus 2y equals to 0. X square plus y square minus 2x minus 2y equals to 0. Now you see the next question. A line L meets the circle x square plus y square equals to 61. Suppose this is the circle. A line L meets the circle x square plus y square equals to 61 at A and B. P minus 5 comma 6 is a point such that PA equals to PB equals to 10. You see, watch carefully. This P lies on this circle, no? Because minus 5 square is 25, 36, 61. Suppose we consider P here. So this distance is 10, PA, and PB is also 10. Now equation of L we have to find. Watch carefully. Let we find a circle whose radius is 5. Whose radius is 5. So radius is 5 means this circle and center is P, suppose. What is P here? Minus 5 comma 6. So this circle will be like this. Now this circle is center P minus and radius is 10. So these two circles intersect here. So this will become the common chord. So the length, sorry, L equals to 0 will become the common chord. So one circle already given, the another circle we can find with center minus 5 comma 6 and radius 10. We know the equation with center and radius is x minus a whole square plus y minus b whole square equals to r square. So minus 4 minus this will be plus 5. This is minus 6. So let me expand this one, x square plus from here y square 2ab, 2 5s are 10x minus 12y minus 12y. Now last is 6 square 36, 5 square 25, that is 61 minus 100. So minus 161 if you take out. So what will be this one? 10 minus 1 9, 39. So this will be minus 39 equals to 0. So this is the equation of this circle, and equation of another circle is given as this is the another circle. So x square plus y square minus 61 equals to 0. If you subtract this two, we'll get the common chord here. That is the line AB. So subtract this one, we will get the common chord minus minus plus. So this will get cancelled. 10x minus 12y. No, this is plus, no, 61 minus 39. So 12, 2, and 5 minus 3 is 2. So it will become minus plus 22 equals to 0. Plus 22 equals to 0. So if you take the common 2, you'll get the answer. If you take common 2, what is left here? 5x minus 6y plus 11 equals to 0. If you take 2 common here, 5x minus 6y plus 11 equals to 0. Now see the next question. If a circle passes through A comma B, suppose a circle passes through the point A comma B and cuts the circle x square plus y square equals to 4 orthogonally, then the locus of its center. We have to find the locus of the center. Suppose let we take the center x1 y1 x1 y1. Okay, so given circle is this one, so its center is 0 comma 0. This is the general formula, x square plus y square equals to r square. R square is 4, so its radius is 2. Suppose this is 2, this is c1. Now what is the condition for orthogonal? You see this circle cuts this circle orthogonally, so we can use this formula, d square equals to r1 square plus r2 square. What is d here? Distance between the centers, x2 minus x1 whole square plus y2 minus y1 whole square. So you'll get x1 minus 0 is x1 square plus y1 minus 0 is y1 square equals to r2 is 2, 2 square is 4 plus r1 means distance between these two. This is the radius of this first circle, this is the radius of this first circle. So x1 minus a whole square, x1 minus a whole square plus y1 minus b whole square. So this is the this condition for orthogonal circles. D square, D is the distance between the centers, R1, R2. Here 2 square is 4. R1 is this radius is nothing but distance between the center and this point. So we can write like this, x1 square plus y1 square equals to 4 plus, now a minus b whole square is a square minus 2ab plus b square plus a square minus 2ab plus b square. So let me cancel this x square y square x square y square. Now when we write locus in place of x1 we have to write x. So I am writing this first. 2, let me take minus common, this will become plus 2ax. Then we write y. If you take minus common, this will become plus 2by. Now if we take minus common, this will become minus, this will become minus, this will become minus. So we take minus common, so this will become plus a square plus b square plus 4 equals to 0. So what is the equation here? 2ax plus 2by minus of a square plus b square plus 4 equals. Now see the question, the locus of the center of the circle which cuts the circles orthogonally is. Let me take the general form, x square plus y square plus 2gx plus 2y fy plus c equals to. Let this be the circle. Now this circle is orthogonal to these two circles. So we can use the condition of orthogonal is 2g dash plus 2f dash equals to c plus c dash. Okay. Now 2g, suppose this is as 2g, or else you take this as 2g. 2g is 4 here. 2g. Now g dash is g. Watch carefully. 2g is 4. G dash is g here. 2f is minus 6. F dash is f equals to c plus c dash. Now bring this here. Okay, let it be like this only. This is one equation. And another equation is this one. Again, this is orthogonal with this. Again, use the condition 2g is minus 4 here. 2g is minus 4. 2g. G dash is g, this one. Plus 2f is 6. F dash is f equals to c plus c dash is 4. Now see here, let me do one thing. Now subtract this 2. You subtract this 2, you see C will get cancelled. So sign will change, this plus, this minus, this minus, this minus. So 4 plus 4, 8g. 4 plus 4, 8g. Then minus 6 will be minus 12f. Minus 6 will be minus 12f. Plus c minus c cancel. 9 minus 4 is 5. Bring this 5 here, it will be minus 5 equals to 0. Watch carefully. 8g minus 12f minus 5 equals to 0. Now watch carefully. We have to find the locus of the center. What is center? Center is minus g minus f. So we have to change this. Okay. In place of minus g, we have to write x. In place of minus f, we have to write y. For locus, in place of minus g, we have to write x. Or you can say like this, minus g is x and minus f is y. That is, in place of g you write minus x, in place of f you write minus y. So 8 into, in place of g if you write minus x, this will become minus x. In place of fy, minus of minus plus 12y minus 5 equals to 0. We have to find the locus of center. Center is minus g comma minus f. That means x is minus g, y is minus f. So G is minus x, F is minus y. We are changing. Now you take the common minus. This will be 8x minus 12y plus 5 equals to 0. 8x minus 12y plus 5 equals to 0. So Alhamdulillah, we have completed 10 questions in this part, inshallah. We are going to continue the next part. This chapter is not so lengthy. Maximum 3 parts are enough for this chapter, inshallah. We are going to continue, inshallah, in the next part.